This is the geometry review for questions 43 through 64. For number 43, in the diagram below of the parallelogram STUV, SV, this side here is x plus 3. VU, this side is 2x minus 1. And TU is 4x minus 3. Now, we need to know that in a parallelogram, the opposite sides are congruent. So these two sides that we have that are opposites must be equal to each other. So we can go ahead and set those two expressions equal to each other to make an equation. So we have x plus 3 is equal to 4x minus 3. Now, bring this x over to the side by subtracting it. Bring this 3 over to that side by adding it. We're left with 6 equals 3x. We gotta get x by itself, divide by 3, and x is 2. Now, that's not the end of the problem because they want the final length of SV. So we have to plug it back in. So take our equation, x plus 3, and plug in the value of 2 for x value. 2 plus 3 is 5. Number 44, what is the value? For what value of x must A, B, C, D be a parallelogram? So again, we're using the properties of a parallelogram, which would be saying that these two opposite sides have to be congruent. This one's a little bit hard to read. That is a plus sign. So we had 12x minus 5 and 10x plus 5. So we're going to set those two equal. 12x minus 5 equals 10x plus 5. We need to combine like terms, so I'm going to subtract the 10x from both sides to get those to cancel out. I'm going to go ahead and add this 5 to the other side, so those cancel out. So now we have 2x equals 10. Divide by 2, and x is 5. And this one didn't want us to solve for a side, it just wanted x. So that's our final answer. Number 45. What is the first step in constructing congruent angles? So the first step would be to draw a ray, AF. Nope, that would, where's AF? AF isn't even on there. So that's not even correct. From point A, draw an arc that intersects sides of the angle at point C. You could, let's go to the next one. From point D, draw an arc that intersects the sides of the angle. Well, that one's going to be the one we're making, so there won't be an angle yet, so that definitely is out. From points A and D, draw equal arcs that intersect both rays, AC and DF. AC and DF. Alright, that works. Now, I really think that D should include one other piece, because in the original angle, we should also probably say that it has to intersect AC and AB. And again, correct notation would be nice too. But D would be the closest thing to the correct answer here, because you don't have to go through C with the arc. So we're talking about this arc right here. We had to make that equal distance from A and D, going through both sides of the original angle and through this one side that we had to start our copy. All right, for 46, Melanie wants to construct the perpendicular bisector of the line segment AB using a compass and a straight edge. Which diagram shows the first steps of the construction? So from both A and B, you're going to have to swing arcs of equal length so that they are more than half the distance so that you get two intersections. This one, they're swinging it from the midpoint, which you would not have, so that's out. This has two different lengths. This one's a bigger circle, and that one's a smaller circle, so that's out. These two both have the same size circles. The problem with A is that the distance that they swung from both A and B was not more than halfway, so we only got one point of intersection. So we wouldn't have a second point to draw a perpendicular line. So A is out as well. On B, they swung an arc of equal length so that we had 2 points of intersection, so that we would be able to make our perpendicular bisector by connecting those two intersecting points. So B is our correct answer. On 47, a perpendicular bisector of DC is AB, and a perpendicular bisector of AB is DC. The intersections of AB and DC is E. Which congruent statement is true? I would first draw a diagram. So we have two perpendicular lines. It doesn't say anything about the lengths of those lines being equal, but it does say that they are perpendicular and that they are bisecting each other. So those two have to be congruent, and these two have to be congruent. One of these lines we're calling AB, one we're calling DC, and then the point in the middle would be E. So just looking at this, the only things that we were able to mark as congruent, because that's all that's here is congruent symbols and talking about segments, the only things that we know for sure are congruent are these two pieces and these two pieces. So right away, I would have to say that we could cross out anything that doesn't have E as part of the congruent statement, because we don't know anything about these two within each other. All right, so like if they don't both have E in it, we could probably cross that off right away, cross that one off right away, cross that one off right away, and now we're already down to those two options. And I'll go back through these to show why the other ones also don't work. But this one, AE and DE, those are two different lines. So that one also doesn't work. DE and CE, those two are congruent, because AB had bisected CD, so that E will split them equally. Now, E is the only correct answer here. If I go back and look at these other ones, CE and CD, well, one of them is half of the other length. That makes no sense. For C, the reason why that doesn't work, AB and AC, AB and CD, those are the two overall segments. We know nothing about them being congruent to each other, so that's not correct. On D, EB and CD. Well, that's way wrong. That's half of this segment, and the whole segment over here have no relation whatsoever. That's, again, completely wrong. The only one that works is E. On 48, Adam is asked to construct the bisector of angle R. Explain the error in Adam's work. So, first thing I notice here is in order to construct an angle bisector, there would have to be an arc from here through both of those sides. There's no arc there. So this point that he had right here and this arc don't make any sense because there's no arc going this way for it to intersect. So we need this arc first. Let's see, Adam changed the setting of the compass, and that doesn't matter. Adam didn't draw a third arc to verify that the second point was correct. Maybe that sounds a little confusing and vague. Adam started the construction at the wrong place. He should have started at point R and drawn an arc across both rays. That's where he should have started the construction. C is definitely the correct answer. Let's just go ahead and read D to make sure that that's not correct as well. Adam started the construction on the wrong way, on the wrong ray, sorry. He should have started on the other ray. And that makes no sense either. So again, C is the only one that works. Like I said, you have to have that arc in order to know where to go from here and swing this arc, because you need a point of intersection. So you have 2 points equidistant so that you can swing the other 2 arcs out in front and create the angle bisector. So he was missing that first arc. On 49, you have been asked to place a warehouse so that it is equal distance from the 3 roads indicated on the following map. Find this location and show your work. So you don't actually have to show your work. You don't actually have to do the construction. They ask you 2 sub-questions here. Now, in order for it to be equal distance from the roads, these are creating a triangle. There are 4 points of concurrency. There is the circumcenter, the incenter, the centroid, and the orthocenter. 2 of them we talk about being equal distance from particular things. One of them is equal distance from the vertices. One of them is equal distance from the sides. The circumcenter, the center of a circle that goes around the triangle, is equal distant to the vertices. The incenter, the center of a circle that's inscribed into the circle, is the point that's equal distance to all the sides. So we want the incenter. So that's actually the answer to part B. So we need the incenter. Now, how would we construct that incenter? Well, the incenter is where all the angle bisectors meet. So what constructions do you need to perform to accomplish the task? We need to construct angle bisectors to find the incenter. Again, that incenter is equal distant to all the sides. So construct angle bisectors to find the incenter, and then the name of that point, again, is the incenter. On 50, what point of concurrency created by the construction within the triangle? Well, here, these are all perpendicular bisectors. Perpendicular bisectors meet at the circumcenter, which is the center of a circumscribed circle around the triangle. That's the one that's equal distant to the vertices. On 51, which type of construction can be accomplished by using the method shown? So here they went from both of these. I see arcs. That it's kind of hard to see the other ones that are really faint, but there's an arc here and there's an arc here. So all they've done so far is drawn 2 arcs that appear to be equal distant from both A and B, both above and below the line. So what they're doing is they could use those 2 points to connect and draw a perpendicular bisector, or you also use that same construction to create a midpoint. So let's see what options they give us. Congruent segment. No, it's not for copying a segment. Segment bisector. Yep. So a perpendicular bisector or a midpoint are a type of segment bisector. So B sounds like it should work. And then congruent angle has nothing to do with angles. Parallel line has nothing to do with parallel lines. So a segment bisector, because both a perpendicular bisector or a midpoint would be a segment bisector. So on 51, what construction is being created by the diagram? So they swung an arc through both sides of the angle, and then from each of these points they're swinging arcs out here in front. So this would be an angle bisector. Let's see. Copying an angle? No. Copying a segment? No. Bisecting a segment? No. Bisecting an angle. Yep, they are creating the angle bisector. B is our correct answer there. On 53. 53, again, some of these were hard to read, so I rewrote them. This is 6x, let me do it in red, 6x plus 5, 5x plus 16, and 7x minus 3. And I had those right on the board. Now, over here, so again, this is a multiple choice question. All right? But you have to know what to do with those three values. Now they tell you it's a parallelogram, but we don't care that it's a parallelogram. This problem has nothing to do with parallelograms. So that information was useless, and it was there to throw you off. What's important is that those three angles that they gave us form a triangle. So we have three angles in a triangle. Those three angles must add up to 180. So 180 equals all three of those add together. So 5x, 6x, and 7x gives us 18x. We have 5 and 3, negative 3 gives us positive 2. Positive 2 and 16 gives us 18, so plus 18. So we just combined all three of those angles. Now we can go ahead and subtract off the 18 to solve for x, so minus 18, minus 18. So that's going to be 162 equals 18x. And then we have to divide off 18, and 162 divided by 18 is going to give us 9. So x is 9. That's not where we're stopping though, because it tells us what is the measure of ACD. So ACD is this angle down here. It's this one. So we're using that part. So we have 7, plug in the 9 for x, minus 3. 7 times 9 is 63. Minus 3 is 60. So 60 degrees for angle C. And on that one, so let me double check my work real fast, because I just realized that my answer key has a slightly different answer. We had subtracted 9, 7 times 9 is 63, minus 3. I think everything's good. Yep, I believe it is B. If I have to go back and correct this later, I will, but I believe it is B. Alright, on 54. The triangles in the diagram below are congruent. If triangle JKL is congruent to triangle OMN, then what is the measure of angle N? Well, so this is the angle that they want us to find. So I'm going to highlight that one in blue. Now, they told us J was 60, and J is in the same place as O, so we know that this one is also 60. So now we know those two angles. We need the third angle. So we're going to take 180 degrees in the triangle, subtract off the two angles that we know, so that's 56 and 60. 56 and 60 add up to 116. 180 minus 116 leaves us with 64. So 64 degrees for angle N. All right, 55. An equilateral triangle and an isosceles triangle share a common side. What is the measure of angle ABC? So, they gave us this angle as 67. Since this angle is 67, this angle is also 67. So, we could figure out this vertex angle, the isosceles triangle, by taking 180 and subtracting off. That's 67 and 67. And that would give us, let's see, 134. So you subtract off 134 and you're left with 46. That's for this angle up here. Once you know that angle is 46, Then it's a matter of knowing what this angle is. Well, this one, it said the other triangle is equilateral. All the angles in an equilateral triangle are 60 degrees. Because again, equilateral triangles are also equal angular, so you can take the 180, divide by 3, and that gives us 60 for all the angles. So our final answer here, we have to combine these two to get A, B, C. So 46 plus 60 gives us a total of 106. All right, for 56, write an equation that could be used to find the value of y. And then it also says, then solve for the measure of angle K. So, two parts to this. First thing they want us to do is write an equation that we could use to solve for the value of y. Well, since this is an isosceles triangle, these two angles, the two base angles, must be congruent. So our equation is going to be 5y minus 19 equals 56. So that should be the first part of our answer. Then we have to find y. So, using the equation we just made, again, first part of our answer, we're going to have to first solve for y. So, add 19 to both sides. And then we have 56 plus 19. It's going to give us a total of 75. So 5y is equal to 75. Divide off 5. 75 divided by 5 is 15. So y equals 15. Then they also want to know the measure of angle K. So we got y. Now we need K. This is K. Well, we don't even need to know this information to solve for K. It's actually kind of useless because we already know that this angle is 56. So if both of these are 56, this one we have to do 180 and subtract the two angles that we already know. So minus 56 plus 56. And together those are 112. So 180 minus 112 is 68. On the next one, 57, the diagram shows quadrilateral ABCD. Which of the following would prove that ABCD is a parallelogram? So, the slope of AD is equal to the slope of BC. So they're saying these two are parallel. The length of AD and the length of BC are equal. So the same set of opposite sides are both parallel and congruent. That was one of our theorems to say that it is a parallelogram. So what this is saying, I'm just going to draw that parallelogram over here off to the side again. They're saying that one set of opposite sides is both parallel and congruent. Again, that is one of our properties. So that one definitely works. Let's go through the other ones. The slopes are equal, so it's saying those are parallel. The length of AB is equal to the length of AD. That makes no sense. What that is saying is that these two are parallel and that these two are congruent. So, doesn't necessarily have to be, doesn't tell us anything else about the other parts. So, that's not necessarily true. Although I don't like that being an answer choice for how they showed the figure up here. If they didn't show a figure, I would definitely say that does not have to be true. So if they said that this diagram is not to scale, again, doesn't have to be true. Length AD is equal to length BC is equal to length DC. So, no, that doesn't have to be true. Again, this could be true in a trapezoid. We could have an isosceles trapezoid with one of the bases equal to the length of one of the legs. Again, I don't like the fact that they showed a picture, but just based on the statement, doesn't have to be true. Length AD, length BC, and length AB, again, have the same idea as C. Doesn't have to be true. You could have an isosceles trapezoid with those. Alright, so the only one that works is A. On 58, Julian and Tammy are considering a quadrilateral ABCD. Their task is to prove it's a square. Julian says we need to show that the slope of AB equals the slope of CD. So let's go ahead and draw this so that we can picture what they're saying. So we want it to be a square. So I'm going to draw it so it looks like a square. A, B, C, and D. So we need to show that the slope of AB equals the slope of CD. So that would tell us that these two are parallel. And the slope of BC equals the slope of AD. So that would tell us these two are parallel. All we just did was classify this as a parallelogram by doing that. So that's not enough to know it's a square. That's enough to know it's a parallelogram, but not enough to know that it's a square. All right, let's go to the other ones. So again, you can draw the same figure. A, B, C, and D. Tammy says we should show AC, so this length here, is equal to BD. All right, so if we have a quadrilateral with two congruent diagonals like that, it has to be one of two things. It could either be an isosceles trapezoid, or if we already knew it was a parallelogram, then we could say that it is a rectangle. So let's go to the next part. Slope AC and slope, let's see, AC and AB, AC and AB equals -1. No, so if they had said the two diagonals, if it was the two diagonals being a slope of -1, that would mean opposite reciprocals, which would mean that they were perpendicular. But this one's doing one of the diagonals, one of the sides. So that's, again, not enough information. So neither is valid here. Neither one is valid. Now, if we had said that these two diagonals are perpendicular, so if the diagonals were perpendicular and the angles and they were congruent, I still don't think that'd be enough information to say it's a parallelogram, because I'm pretty sure you could make a trapezoid that looked like that. Let me see. So again, even if it said it was a parallelogram, still not enough information, because I can make it so that these would be perpendicular and that those two would be congruent. So that still wouldn't be enough information. You'd have to know, first it was a parallelogram, not just a quadrilateral, and you'd have to know a little bit more information there. So you'd have to know if these are congruent and perpendicular. So again, no matter how you look at it, not enough information, not valid. So they're both wrong. All right, on 59, classify the triangle by the lengths of the sides. All right, we need to find the lengths of the sides. So we could use either distance formula or Pythagorean theorem. I like using Pythagorean theorem. So I'm going to draw triangles for each one of these. 1, 2, 3, 4, 5, 6. My 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we got this side. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. And then we have one more side. Let me grab another color. One, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Just looking at how different these dimensions are, I don't think the third side of any of these triangles could possibly be congruent. But I'm going to do this real quick. So, to set up this top one, again, I could say c squared equals 5 squared plus 13 squared. So, doing most of the work in my calculator this time, I have c squared equals 194. I don't have to go farther than that because, again, I'm going to take the square root of that number. But I'll go ahead and do it since it's not that much extra work. Because I'm sure a lot of people probably did it. Again, it's not a perfect square. But it would come out to, again, as a or 13.928. Let's do red next. This one I did in red, c squared equals 6 squared plus 11 squared. C squared equals 6 squared plus 11 squared is 157. Again, completely different answer here. So square root of 157, again, doesn't come out. So, again, we get another decimal. And finally, the blue side. This one also is not going to come out to a nice number. C squared equals 6 squared plus 7 squared. 6 squared plus 7 squared is 85. Take the square root of that. Again, like I said, it doesn't come out to a nice number. .22. So, none of them are the same. Therefore, this is scaling. On the soccer field, Cameron needs to pass the ball and wants to make the shortest pass possible. Who should he pass the ball to? Arthur or Jamie? So, here's Cameron. Arthur or Jamie? Here's Jamie, there's Arthur. Well, it's hard to tell. I think Jamie looks closer. But let's go ahead and draw ourselves in a triangle. Again, you could use distance formula, but these are some really big numbers to do with distance formula. So he's up here at 45. He's down here at 15. The difference there is 30. And this 40 to 55 is 15. If I did this other one over here, again, going all the way over here, the difference between these two, we have from 15 all the way out to 55. So this is 40. And then this side, 30 to 45, that's 15. Now, just looking at this, I don't even have to figure out the other side, because if this is 30 and 15 and this is 40 and 15, the one with the two shorter sides is going to have to be the one that works, because this side will have to be shorter than this side, just based off of the dimensions. So we don't have to do the work. If you wanted to, you could figure out the length, but Jamie would be closer. Again, that only works because one of the two sides was equal, and then the other side, we had a longer distance, so we don't really have to figure it out, because if you have one side that's the same and the other side that's longer, the hypotenuse is going to be longer on the one with the longer dimensions. So it is Jamie who is closer. All right, on 61. Which statement is true about the two lines whose equations are given below? So, lines are parallel, lines are perpendicular. We need to solve for y in order to figure this out. So, bring values across and get this set equal to y. The first equation, we bring 3x across, so we'd have negative 5y equals negative 3x minus 3, divided by 5 and negative 5, so it'd be 3/5 x plus 3/5. Let's do the same thing for the other one. Bring the negative 2 across by adding positive 2, so 2x minus 8 These two, they don't have the same slope. They don't have the same y-intercept. So they should just intersect. Let's see, are they perpendicular? Nope. Are they parallel? Nope. The lines coincide? Nope. The lines intersect but are not perpendicular. That would be the one, B. On 62, which equation describes a line that passes through 6, -8 and is perpendicular to the line described by this? First, take that second equation and rewrite it so that it's in slope-intercept form. So bring the 4x across. That's -4x plus 6. Divide off the -2. We get positive 2x minus 3. Now, the slope here was 2. We want perpendicular, so can't have the same slope, so it's neither of those. In order to find the answer a little bit faster, we know a point. Instead of trying to plug this into point slope form and solving, it's multiple choice. Just plug the value in and see which one works. 6 plugged in here. -1/2 times 6 is -3. -3 minus 5 is -8. A is our answer. Number 63, write an equation in point slope form for the perpendicular bisector of the segment with endpoints. Here we need to find slope and we need to find our midpoint. So slope is going to be the change in y over change in x. So that's 2 over 7. Again, we want perpendicular, so that's the same. We don't want the same slope, so, and that's not even opposite reciprocal, so that's not good. There's opposite reciprocal. This one's out. There's opposite reciprocal, so we're down to A or D. Now we need the midpoint to find out what point they used. So midpoint of those two is the average of the x's, average of the y's. -2 plus 5 divided by 2. 2 plus 4 divided by 2. -5 plus 2 is 3. So that's 3/2. That's 6 divided by 2 is 3. So we got 1.5 and 3. That's what they used in A. And finally, for 64, the equation on the line perpendicular to line, this is very similar to this one. We already know the slope. So we want perpendicular, opposite reciprocal. So get rid of those two that were the same. It's down to these two. Plug your point in. If I plug 6 in here, 2 times 6 is 12, plus 14 is a really big number, not -4. 2 times 6 is 12, minus 14 is -4. D is the correct answer. So that was everything from 43 up through 64.